Guys, welcome back. Today I'll be discussing this topic 6-6 trapezoids and kites. A trapezoid, the shape looks like either like this or like this. Here are the properties of a trapezoid. The first property is that a trapezoid, which is also a quadrilateral, it has only exactly one pair of pedal lines, like this and this. A trapezoid is a quadrilateral with exactly one pair of parallel sides. And these parallel sides, they are called the sides of the trapezoid. Sorry, these are called the bases of the trapezoid. The non-parallel sides of the trapezoid, they are called the legs of the trapezoid. The angle between one leg and one of the bases, this one, is called the base angle, or the angle between this leg and this base is also called the base angle. So is this one and this one. So in this trapezoid, A, B, C, D, angle A and angle B are one pair of base angles. Angle C and angle D are other pair of base angles. If the legs of the trapezoid are congruent, then the trapezoid is called an isosceles trapezoid. discuss the theorems on isosceles trapezoid. So the isosceles trapezoid is the one that mostly we're going to have theorems on. Three theorems on isosceles trapezoid. And here is the first theorem. If a trapezoid is an isosceles trapezoid, then each pair of base angles are congruent. Each pair of base angles is congruent. That means if we have a trapezoid like this, and if this is an isosceles trapezoid, that means these two legs are congruent, then each pair of base angles are going to be congruent. So let's say this is trapezoid A, B, C, D, then this is one pair of base angles that are going to be congruent, and this is the another pair of base angles that's also going to be congruent. So if A, B, C, D is an isosceles trapezoid, then angle A is going to be congruent to angle B, and angle C is going to be congruent to angle D. Here is the second theorem on isosceles trapezoids. If a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. For example, if we have this trapezoid A, B, C, D, and if we have one pair of congruent base angles, let's say angle D is congruent to angle C, then this trapezoid will be an isosceles trapezoid. That means these two legs are going to be congruent as well. So let me write it down. If angle C is congruent to angle D, then A, B, C, D is an isosceles trapezoid. Here's the third theorem on isosceles trapezoids. A trapezoid is isosceles if and only if its diagonals are congruent. As you know, if and only if stands for biconditional statements. That means the converse of this statement is also true. So, for example, if you have this trapezoid, so if A, B, C, D is a trapezoid, and these diagonals will be congruent if a trapezoid is isosceles. And the other way it is also true. if ABCD is an isosceles trapezoid, then AC is congruent to BD. The converse of this statement is also true. That means if AC is congruent to BD, then trapezoid is isosceles. So here is another theorem on trapezoids. Now this theorem is not on isosceles trapezoid. This works for all kinds of trapezoids. So let's have a trapezoid something like this. And if I connect the midpoints of the two legs, midpoint of this leg, let's say, is this point, and midpoint of this leg is, let's say, this point, and this segment is called the mid segment. This is the midpoint, so this equals to this, and this part of the segment equals to this part because this is the midpoint. So let's say A, B, C, D is the trapezoid, E, F is the mid segment. According to this theorem, the mid segment of the trapezoid, or of a trapezoid is parallel to each base and is half of the measure of the sum of the bases. So basically, in any trapezoid, if EF is a mid segment, if EF is a mid segment of trapezoid ABCD, then according to this theorem, EF is parallel to AB and is parallel to DC. Also, the measure of EF is going to be half of the sum of the two bases. These are the two bases. Base, base. So this is one of the bases, this is the another base. So let's do a question on this. In this figure, LH, segment LH is the mid segment of the trapezoid FGJK. What's the value of X? What's the value of one of the bases? So we're going to say, according to mid segment theorem, LH, the measure of segment LH is going to be half of sum of the two bases, sum of the measures of two bases. So LH is 15, it's half X plus 18. So you can multiply both sides by 2. This 2 cancel with this 2. This is 30. 30 equals to X plus 18. Subtract 18 from both sides. 12 equals to X, or X equals to 12. So the measure of segment FG is 12. Thank you very much.